Now we are starting with page 44. Try this problem. Let's see. It's a special triangles angles problem.
How should we go about solving this? Well, we could see that this would be 45 degrees, this would be 45 degrees. This is an isosceles triangle after all. We could see that this is also 45 degrees, this is 45 degrees, which means in triangle AFH, the side lengths would be x, x, and x root 2. This right here would also be x root 2 and x root 2. BC in total is equal to 3 root 6. So x root 2 plus x root 2 is equal to 3 root 6. What is x root 2? Well, 2x root 2 is equal to 3 root 6. X root 2 is equal to 3 root 6 over 2. It's equal to 1.5 root 3 x's. How do we find FH? Well, x is equal to 1.5 root 3, which is our final answer.
That's great. Thank you. So this one, chapter 3, page 46, side problem.
Well, we don't see a typical triangle. We don't see a 30, 60, 90. Not yet. But see, we have an obtuse angle, and sometimes these can be broken down into two smaller angles. Let's try to break it down. Let's say we want to have 60 here, because this would be 30, 60, 90. This means it would be 45 on this side. Ooh, we have a 90, 45, 45 triangle, as well as a 30, 60, 90 triangle. These triangles, we know how to find the side lengths. So AC is equal to 6 root 6. This means A root 2 is equal to 6 root 6. What is A?
So we divide each side root 2, which is 6 root 3. Great.
Yes. So 6 root 3, 6 root 3. Now, how do we do the 30, 60, 90 triangle? We know this is A root 3 and 2A. So we know A is 6 root 3. Then A root 3 is 6 root 3 times root 3 is 6 times 3 is 18. And 2A is equal to 12 root 3. So what is BC? It's equal to 18, which is this section, plus 6 root 3, which is our final answer.
18 plus 6 root 3 is our final answer. The value, the length of the BC. Great. Chapter 3, page 47, side problem. I'm going to make this one a bigger.
So how should we go about solving this one? Again, we see an obtuse angle. Instead of breaking it down, though, we can extend this triangle.
Let's extend this side, Eva. So from here, right?
Yeah.
I'm going to make the extension for you.
Thank you.
For this side, and then connect the other side, right?
Yes.
Okay, sounds good.
Why we extend here is because this is a straight line. So this must be 30 degrees to add up to 180 degrees. And this is 90 and this is 60. So thus we have a 30, 60, 90 triangle. 3 root 3 refers to the height, which is A root 3. A root 3, and 2A. So if A root 3 is equal to 3 root 3, A is 3 and 2A is 6. So now, how do we find KL? Well, we know for the bigger triangle that this is 9. We know this is 60 degrees, 90 degrees. Thus, the angle over here must be 30 degrees. We have yet another 30, 60, 90 degree triangle. So we know that A is 9. That means A root 3 is 9 root 3, which is KL. KL is 9 root 3.
Great. Can I attempt to show second method for this problem?
Yeah.
Okay, we did extension to the left. Now I'm thinking we may complete this triangle this way. Okay, let's see. Once we make this way, we see that this is again 30 degree. This one becomes 60 degree, and then this is also, of course, 30 degree. So let's see. We have the length 3 right across 60 degree. That means this squiggly part has to be root 3. Then this part has to be what? Ava, what do you think this part has to be? Let's say this is
across
H,
from
HM.
the
Yeah, hypotenuse, right? It's going to be
yes. Well, we
2
have root 3 for across the 30 degrees and
2 root 3, right?
Yes, 2 root 3.
So now when we think of the big whole triangle, and when we think of this one, right? Then what do we see that the length right across the 30 degree is 5 root
5 root 3.
What would be the hypotenuse would be?
The hypotenuse is equal to 10 root 3.
10 root 3. Then I am almost coming to your answer, what you just found.
Yes, we just have to subtract root 3 because that's what we extended.
That's another solution. Okay, great. So now this one is a page 48, chapter 3, side problem. This is a right triangle, what we call isosceles right triangle with M90. Let's attempt to create MKML. Okay, great. Which is perpendicular, 90 degree. Point D is on the hypotenuse KL. Do you think, Eva, should I replace point D close to the K or close to the L?
You should, okay, so it says that DL is 2 and DK is 4. You should place it closer to DL because there's a smaller length in between.
So if I say this is this DL is 2, and then DK is 4, then I can connect M and D. That is my figure, right? It is important to make proper figure, at least close to proper. It's essential to see and then move forward to your solution steps. Okay, then, isosceles right triangle. I forgot to make, this is important. And what's our responsibility, our job?
When always, we see an isosceles triangle?
Yes, always what?
Draw perpendicular foot.
Yes, always, always. That's your number one job, perpendicular foot. So once you make a perpendicular foot, these guys makes what? Isosceles. Is it bisect? What bisect? What do we say? They are equal. It makes KL into 2 pieces, equal pieces.
Yes.
Then what's the value of HD and KH?
HD and KH. HD would be 2, right? Because 4 and 4. Or
4 plus, what is the whole length? KL. 6.
Oh, 6. Sorry, the whole thing is 6. So that means it'd be 3 and 3, which means that HD is 1.
1. Great. Then I can see that this is also same, right?
Yep.
Because we did previous chapter or this chapter that is 90 degree and this three are equal each other. We are almost getting the final answer, dm. Then how do we get dm?
We could use the Pythagorean theorem. 1 squared plus 3 squared equals, say, x squared. That means x squared is equal to 10. X is square root of 10.
Then dm becomes square root of 10. That is our value of the length of dm. We got it. So now another fun problem, page 50, chapter 3, side problem. Okay, where should I start? I'm excited to show this one because I know you guys, Geotopia, and you work this problem. Now you are curious about the scene solution. First of all, you just pause the video and try yourself first. Okay, let's see. I am going to start focus on this guy. And I'm going to put this one 2 root 3x. Sorry, 2 root 3x. And then you will see why. What's the reason for doing that? If I say this is 2 root 3x, what's the value of AB? AB becomes what? Root 3 times 2 root 3x, which is 2 times 3 times x, which is 6x.
Mm-hmm.
So whole AB becomes 6x. Okay, that's great. Then here's the one thing. We did previously, what's our job, or one of things you can do, parallel line, right?
Yes, the midpoint parallel line. Right?
Great, midpoint. I like the idea. Now this is, let's say, M. And then this M becomes parallel, but this, okay, let's say this is equal. What do you say about MD?
Would it be, since the triangles are in a 1:2 ratio,
Mm-hmm.
the smaller to the bigger, it would be half as much, so root 3x.
Root 3x, great, we got that one. Now I would like you Eva, to think about how do you manage AM, EB, and ME by using this one. So let's see. So first of all, you have 6x, right?
Mm-hmm.
All things is 6. What do you think this part would be?
Well, the ratio is 2 to 1, so this could be 3x, and well, that would also be 3x then.
3x, but how do I manage this one? If I say this is 2x, then this part would be what?
1x.
Why?
Because 3x plus 3x equals 6x.
But how do I know this is 2x? Because
using the ratio.
Because this is 6x. Let's say EB. Oh, sorry, AE. Sorry, this is 4x, right? And then this is 2x. That is the only thing makes 6x, right? 2x plus 4x, 6x. Okay, now do you see that something interesting happening here? This triangle, green triangle.
Ooh, I do see something interesting. It looks to me like across, this would be a 30, 60, 90 triangle because I see an x and then a root 3x. So I'm assuming the hypotenuse then is 2x.
But that's okay. Let's focus the angle. AED. So this angle.
Oh, I think it'd be 60 degrees.
Why?
Well, because it's a 30, 60, 90 triangle, and this angle right here would be 30 across an x, so this thus is 60.
That is correct. Wow, we solved the question. That is kind of challenging problem, but we got it. That was the solution, which is 60 degrees. Let's see. Chapter 3, page 51, side problem. We are going to use similar idea what we used previous problem. Making parallel
Midpoint.
to yes, midpoint. This guy. Let's say if I say this is 2a, this one is 2a. What do you think this length?
I think it's a root 3.
Or half of?
Oh, yes, also half of 2a, so a.
Which is a. Great. Then can you focus on this green triangle, please? What do you see?
Oh, I see an A and I see a 2A. Perhaps this is a 30, 60, 90 triangle?
Yes. Which one is 30? This one
right
is
there.
30. And this part is
60.
60 degree. Then what is this part? This one 180 minus 63, right?
Yes.
Because they add supplementary. Then the actual angle MEDC becomes 60 plus 180 minus 63, which is 180 minus
3.
177. Another nice problem so far. We use mostly 30, 60, 90 triangles feature.
Yes.
This cute, nice side problem from page 52, Geotopia Volume 1 book. What comes to our mind first? I feel like.
Yeah, I feel like making a right triangle out of this, an isosceles right triangle.
45, then
60.
60. Let's put the giving information. AB
is AD, there's 3. That means DB is 3 root 2. Oh, another isosceles triangle we have.
How?
Well, because
This
DB.
one?
Yeah, that triangle is also isosceles.
Further. Okay, isosceles and also what?
Also an equilateral triangle, which means that it also is 3 root 2.
What are we looking for?
DC, which we just found out.
Very nice. Perfect. We got this problem very nicely. So, page 52. This problem is asking octagon. Okay, find the height of a regular octagon with a side length of 8. So I would like to first show you how I make proper octagon. It's not proper, but at least close to proper. I would like to do, first you draw a square, and then you go from here to here. Then you go from there to, wow, not bad. So this is called octagon. What do we know about octagon? 1, of course, 135. This is 45. This is 45. So everything is 45, right? Then just, why don't you just connect this, everything here, connect everything here, connect here, then it will make your job easier. Okay, great. Do you see that one side is 8? But I really don't know this part. To find the height, I need to figure out this part. Let's see. How do I find this part? If
Oh,
this is
well,
8, yes.
it looks like a 45. Is it a
Mhm.
45, 45, 90 triangle?
Yes, both this part, right? This corner.
Yeah, that makes a rectangle.
Then how do we find, instead of multiplying by root 2, we divide by root 2. 8 divided by root 2 becomes 4 root 2. And 8 divided by root 2 becomes 4 root 2. Then when we add these 3 pieces, 1, 2, 3, this
You
sum
get 4 root 2 plus 4 root 2 plus 8. So
gives us 4 root 2 plus 8 plus 4 root 2. That's height of this regular octagon with a side length of 8. That is understandable. We have 2 nice problem left. These 2 problem uses another two special unique triangle. One of them is 15, 75, 90 triangle, which is this one. I would like to just remind you, if you have 15, if you have side A, right across the 15, 75 would be root 3 plus 2 times of that short side. The second feature of the 15, 75, 90 triangle is, this is also very nice to see, h and 4h. Hypotenuse is 4 times of height, shortest height. Let's see. And I'm going to use the maybe first one, this h and 4h1. If the area of this triangle is 8, and I will say h times 4h over 2 is 8, 2h squared is 8, and h equal 2. So that's good to see that this is 2. So where am I looking for? This is 15. Okay, I am looking for this part, AH. Then I can see that AH, I can focus on this green triangle again, which is 15, 75, 90 triangle, with the shortest side is giving. The shortest side is 15. Then I can use this property, which is AH becomes 2 times root 3 plus 2, which is 4 plus root 3. That's my length of AH. Okay, if you don't know this one, please take note. These 2 features, it's useful. Of course, when it comes to trigonometry, you can always use trigonometry, but knowing this directly is also helpful. Now we come to our chapter 3 side problem, page 54. This problem, another special triangle, 22.5, 67.5 triangles. What is the feature of this one? Okay, the feature, main feature is if the shortest side is A, the longer leg becomes A times root 2 plus 1. And other way, if I say if this guy is x, then this will be x over root 2 plus 1, vice versa. Okay, let's focus on this given information so far. A, B, I am going to, that's interesting. AH, if I say this one is A, then what is the value of this guy? A root 2 plus A, right? Yes. Then, what am I going to do? And what's AB is going to be what? A times root 2. Then this is going to be A root 2 minus A. Okay. Then, so how do we solve this question? So actually, let's see. I noticed that this is right across the, it's not going to be this way. It is going to be other way. That means this part is not multiple of root 2 plus 1. It is divided, A divided by root 2 plus 1. Then it's going to be A times root 2 minus 1, root 2 minus 1 times root 2 plus 1, which is A root 2 minus A. We end up with finding this HC, the value of HC, A root 2 minus A, which is as same as this guy. It gives you 45.